Today we're going to solve radical equations and inequalities. And as always, what you really need to remember is that math is consistent. Not much has changed. We just need to do some practice and be careful about checking and looking for what we call extraneous roots or extra roots. So here we go. We're just going to go through 5 examples and be done. So example 1, we're going to solve 2 times the square root of x plus 1 equals 4. Well, you have to get that square root of x plus 1 alone because x is buried in there. And you can't undo that until you've gotten the rest of the stuff near it away. So we have 2 times the square root of x plus 1. So first we'll divide both sides by 2 and get the square root of x plus 1 equals 2. And then you would do what you've always done. We undo square rooting by squaring. And what you do to one side, you have to do to the other. So I have x plus 1 equals 4. Subtract 1 from both sides, and x is equal to 3. Now, something you always need to do when you're solving square roots or absolute values or any complicated equations is check, because oftentimes we get extraneous or extra roots. So always take the time to go in and check. Store that value in your Inspire, and then plug in the original equation and see if you get true. Or when they're littler, you can just plug in your head. So x is 3. So 3 plus 1 is 4, the square root of 4 is 2, 2 times 2 is 4, this checks. So you can either check quickly in your head, or use your Inspire to be safe. Another quick note I want to make about this one is that now that we know about our rational exponents, when you had that square root of x plus 1 equals 2, if you're not entirely sure how to undo that square root, you could write it as a rational exponent, as an exponent of 1/2. And then remember what we said the other day, you would multiply by the reciprocal of that 1/2, which is 2, to make it go away. And what you do to one side, you do to the other. So you're raising both exponents to a 2. And you end up with your x plus 1 equals 4, either way. So you can know to undo square rooting by squaring, or you can change that square root to an exponent of 1/2, and then raise it to its reciprocal. Okay. For our second example, we have the cubed root of 2x minus 9 minus 1 equals 2. Again, you have to move everything away from the place where your x is hiding. So first I'll add 1 to both sides and get the cubed root of 2x minus 9 equals 3. And now this is a cubed root. To undo cube rooting, I will cube both sides. Or again, if I raise that to the 1/3, I would multiply it by 3. Or raise both sides to the 3rd to make it an exponent of 1, whichever way you see it. So cubing undoes cube rooting, and I'm left with 2x minus 9 equals 3 cubed, which is 27. Now I add 9 to both sides and get 36. Divide by 2, x is 18. Again, take the time to check into your original equation and make sure it works. I'm going to leave the checks up to you to make the video a little bit shorter. For example number 3, I have to solve x plus 1 equals the square root of 7x plus 15. So again, I have a square root, and I need to undo it by squaring. So I'll square this side, which means I square that entire side. Now you need to remember, when you're squaring a binomial, that's really double distributing. So this is x plus 1 times x plus 1 equals 7x plus 15. So you have a little bit more work to do. Double distribute, x squared plus 2x plus 1 equals 7x plus 15. And now you need to remember from a previous unit how to solve a quadratic. You have a squared term, set the whole thing equal to 0, and hopefully it will factor. If it doesn't factor, use the quadratic formula, or complete the square, or graph it to find the zeros. So I want this to be my 0 side, since x squared is over here in positive. So I'll subtract 7x and subtract 15. So x squared minus 5x minus 14 equals 0. I need to find 2 numbers that multiply to negative 14 and add to negative 5. And they are negative 7 and positive 2. Because my leading coefficient is 1, I can do the quick factoring and I don't need to do the product sum split the middle thing. Set both of your factors equal to 0. X is 7 and x is negative 2. Now, I need you to take a minute always to check this. Because again, this is a our first example of when we might get an extraneous root. So if you plug in 7 to your original equation, we have 7 plus 1, and we're wondering if that equals the square root of 7 times 7 plus 15. Well, this is 8, and does that equal the square root of 49 plus 15? 49 plus 15 is 64, and the square root of 64 is 8. So 7 checks. Now we plug in x is negative 2. So we get negative 2 plus 1, and we're wondering if that equals the square root of 7 times negative 2 plus 15. Negative 2 plus 1 is negative 1. Right away, we cannot square root a number and get a negative. So that is an extra root. You don't erase it. You just put a nice X through it to say, oops, in this case, it's an extra answer because I was starting with that square root. Okay, for our last equation to solve, and then we have one inequality and we're done, we have 2x all to the 3/4 plus 2 equals 10. So again, we need to get this alone by subtracting 2 from both sides. We have 2x to the 3/4 equals 8. Now this is in fraction form. We might as well leave it alone. We need to make that exponent a 1. We multiply by its reciprocal to do that. And what you do to one side, you do to the other. So we'll raise our 8 to the 4/3 as well. Now, this is a 1 exponent, so this is just 2x equals 8 to the 4/3. Well, you need to know that that means the cubed root of 8 to the 4th. So 2x equals, the cubed root of 8 is 2, so we have 2 to the 4th. 2x equals 2 to the 4th is 16, divide by 2, x is 8. And when you check that, it works. So that's how we solve radical equations. We do need to talk about solving radical inequalities as well. So math is consistent. To solve any inequality, you pretend that it's an equal to sign for a bit, and then you need to think a little bit more at the end. So here is my x buried under the square root. I'll first divide by 3 to get it alone. So I have the square root of x minus 1 is less than or equal to 4. Undo rooting by squaring. X minus 1 is less than or equal to 16. Add 1 to both sides, and x is less than or equal to 17. So that's part of your answer. Now, the thing you need to be worried about with square roots is that you cannot get a negative number under a square root. When we solve for all real numbers unless it says otherwise. So you also need to account for the fact that x minus 1 has to be positive. So you also need to solve x minus 1 has to be greater than or equal to 0. We cannot have a negative under that square root. When you solve this, add 1 to both sides, and x is greater than or equal to 1. So in the end, we have x is less than or equal to 17 and greater than or equal to 1. In other words, x is in between 1 and 17. And again, you can check that. You can plug in 1, you can plug in 17, make sure it works. You also should plug in numbers that are not in that range or domain and make sure that they don't work. And I'll leave that again for you on your calculator. That is it. Have a great night.